Hello everyone, this is the Promotory channel. Today we're going to take apart this engine. This engine was removed from a bus. So this PAZ bus belongs to our company, but the engine installed here is a Cummins. So the reason this engine was removed is because it's leaking oil. There's oil in the intake manifold, oil in the exhaust manifold. They already installed a new turbocharger here on the spot. Thought maybe the turbo was throwing oil, so they put in a new turbo, but the problem didn't go away. And also the engine is venting crankcase gases. The breather just has a hose going down under the engine and gases are coming out of it. So it was decided to remove the engine and completely disassemble it. We take it apart, inspect it and see what happened to it. Maybe we're in the cylinder-piston group or something like that. We disassemble, inspect for defects, buy parts and reassemble. So the engine was removed from the car and brought to my workshop on a frame like this. Now my task is to remove the gearbox. I also want to show that the gearbox installed here is a ZF model S542. It's quite small in size, about the same as a Zavod Imeni Likachova gearbox. I've never seen such small ZF gearboxes before. Usually the ones I work with are much bigger, starting from the S690 and so on. I've worked on 8-speed, 16-speed and so on. I haven't worked on one like this before. It would be interesting to take it apart, but the gearbox is fine, so we won't touch it. I'm taking off the gearbox, removing the engine from the frame, unscrewing the bolts and mounts, then moving the engine to the workbench. There we need to check if the oil has been drained. Since it wasn't drained evenly, then we start disassembling, removing the manifold pipes as usual. We can see the engine. It's a common rail system with a fuel pump, fuel rail, and here are the fuel lines. Over there we have the injectors with wires, solenoid valves. That's it. So that's the scope of work we have. Let's get started. So I removed the flywheel, took off the flywheel housing, and we can see the timing gears are located at the back of the engine. That is under the flywheel housing. It's about the same as on MN 2866, for example. So this is our camshaft gear. Here we can see there's a mark, and the gear that's on the crankshaft, we can't really see it. From this part, there's a tooth that should align with this mark, and it just has a bevel like this at an angle. I don't know how well you can see it on camera, but you can see it. All the teeth are at a 90-degree angle, and this one here is ground down at a 45-degree angle. These are our timing marks. Only the crankshaft and camshaft are aligned. Everything else is installed randomly. Here we have the compressor, here we have the fuel pump, and we can also see there's an intermediate plate here. Now I need to remove the gear from the camshaft and also unscrew some bolts around here, basically all around, and take off this intermediate plate, and then I'll just have to remove it. Here we also have a plate on the oil pan side, and in the front I need to remove the pulley and the front cover, and that's basically it. Next we'll take out the pistons, install the shafts, and so on. So far I haven't found anything critical under the cylinder. There's a slight wear there, you can feel it by touch, but it's really minor, literally less than 1/10 of a millimeter, even less. We can see carbon buildup on the pistons, showing that oil was burning. Additionally, we can see this carbon layer on the valves of the cylinder head. For now we have no ideas about the cause, and as usual we won't speculate. Now we'll first completely disassemble the engine. Then we'll also remove the valves, take them out and check the condition of the guides, the seats and so on. We'll draw some conclusions at the end. And 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 here, for example, the top compression ring, you can see how loose it is in the groove, meaning the ring itself is worn out. And you can also see the oil scraper ring, it's almost completely worn smooth. So I think that if you install it in the cylinder liner now, there will be a gap, well, starting from, I don't know, 1/5 of an inch. Our rings are worn out, causing wear on the cylinder liners, so we have 100. We need new pistons because the groove is worn out, and also pistons assembled with rings. I'm not sure, maybe we can just leave the piston pin bushing as is. Alright, these are just some initial thoughts for now. Later we'll take it apart, take a look, clean everything, take measurements, and of course the bearings will be new. Alright, pistons are clear. Let's remove the crankshaft and camshaft. Well, I don't think there will be any questions about the camshaft. At first glance, everything seems fine with the camshaft. Alright, so I took out the camshaft and the lifters, and basically there are no questions either. We're keeping the old camshaft, and the lifters will also stay the same. And here's what I want to say. We can see that the lifter is small, but the engine itself is also small. Yes, but this support pad here, which rests on the cam lobe, has such a large diameter. That is, it's even bigger than, for example, on a MAN where it's 2876, or on a Mercedes and so on. So, I'll immediately take measurements to see the wear in the cylinders. By touch, you can feel the wear at the level of the second compression ring, or even around the oil scraper ring. There's a step there. You can feel it well, but it's smooth, not sharp. Usually this kind of wear happens when the engine is taking in dust. So let's take some measurements. I set the gauge to 102 mm. Our piston size is 102, and let's check. Here we have 102. 102. Here's the most worn spot. So at 90 degrees, so, as we can see, the biggest wear is on the third cylinder, as I said, around the second compression ring. That means the first compression ring is already so worn out that it doesn't create any resistance at all. And in this spot, carbon buildup is already accumulating on the liner itself, and it's already scraping the liner. It's specifically the second compression ring, and we can see it here. In some places, we even have almost 3/10 of a millimeter. Here I found the biggest bit, it's minus 28 hundredths, that's already 0.28. Repair pistons are needed, so I will recommend getting repair pistons. The block will go for machining, so it will need to be bored and honed. Well, I don't know how it will all turn out for us. I don't rule out that standard size pistons might be purchased, and we'll just install them as they are. I'm just thinking out loud for now. We'll see what gets decided. Right away, for clarity, to understand the thermal gap in the piston rings. This is our oil control ring. Well, it's about 3 to 4 millimeters here, maybe 3.5. This is our second compression ring, and here the gap is about 1.5 to 2 millimeters. And this is our top compression ring. Here it's also more than 3 millimeters. So, I want to sort out the valves right away and check the condition of the valves and the guide bushings. Then we'll draw some conclusions. Upbeat music. I spread out and removed the valves, and what can I say? with upbeat music, basically. The valves seem like they need to be replaced. That is, the working edge itself is already thin. You can see it's worn out. Well, in general, I don't know, we'll see. I'll clean them, maybe try to machine a couple of valves on the lathe to see what the result is here. And then we'll make a decision. As for the valves, I won't say anything for now. We'll keep working with them and see. So as for the guides, some of them definitely need to be replaced. Like, for example, on the third and fourth cylinders, the exhaust guides, and on the intake valve, there's a pretty big play. For example, if we take the first cylinder, the intake valves, they still seem to be okay. And, well, in general, I'll clean the head too. As for the valves and the guides, I won't say anything for now. I'll clean them thoroughly and then we'll see if resurfacing is needed. We'll also make a decision about the guides after that. With the engine disassembled, let's summarize. Well, the overall condition of the engine is actually pretty good. Considering its mileage, if I find out, I'll write here how many miles this engine has already done. What's the main problem? As I thought, it's wearing the cylinder piston group. Why did this happen? We'll also take a look. I'll check the entire intake system, maybe some hoses or something like that. Dust might be entering the manifold and bypassing the filters. So what should we do? Well, ideally, of course, we'd use repair pistons that are 0.5 mm larger, so 102.5, and have the block bored and honed. Install new repair pistons with new rings. That means for the rest, the bearings need to be replaced too, obviously both the main and connecting rod bearings. Well, that's basically it, I guess. Naturally, all the gasket seals and so on need to be replaced. Also, the fuel injectors will need to be sent out for testing. As for the rest, everything is actually pretty good. The crankshaft stays as it is. I'll just blow it out, wash it and polish it. Same with the camshaft. No issues there either. As for the connecting rods, I'm not sure yet. I'll take another look, but maybe we won't even need to replace the piston pin bushing. Well, I just mentioned the cylinder head. I'll clean it. And I'll also check if I need to replace the guides or not. And the same goes for the valves. And I'll also say a couple of words about the engine itself. It's so small and compact. In my opinion, everything is made quite well, and considering how long it's been running, its condition is actually very good. I'm starting the assembly, so the engine block has already been through machining, and as for the main bearing seats, everything's good. The cylinder head mating surfaces were also machined well. Well, more precisely, the block was bored out to fit oversized pistons for repair. On this engine, the block isn't sleeved. Instead, larger diameter pistons are used and the block is bored out. It has been bored. They did the honing, but I don't know how well you can see it on camera. On this cylinder, it turns out there's no honing in the middle, so it wasn't done very well. I've already taken measurements now. I had a case like this before. After boring the engine, Bulgarian D 3900 engine from a loader, I had to take the engine apart again. We were losing oil, and after I disassembled the engine again and took measurements, it turned out that the cylinder was shaped like a barrel. Here I took the measurements. Everything is basically fine here. There's about a 100th of a millimeter taper. The size increases by 100th toward the bottom. Also, there's about 1 to 1.5 hundredths of a millimeter of ovality. I'll show you on a cylinder soon. My bore gauge is over there. I'll show it later. The block just came back from machining. Now my task, as usual, is to remove the old sealant and old gaskets. Somewhere here, for example, to chase the threads, blow it out and clean the oil channels. So I'll be working with the block for a while, and then we'll start assembling. That includes the camshaft, crankshaft and pistons. So we'll have a new cylinder head. There's a box on the shelf over there with the new head packed inside. I'll explain a bit later why we had to get a new head and show you what was wrong with the old one. I'll talk about all that as we go. I've already done the prep work. Almost everything is cleaned. For example, you can see the camshaft here. The covers are washed, the filter housing, and so on. The connecting rods are cleaned, and the fuel pump too. So that's all on this table, and over there on the other table, and there's also some stuff on the shelf. Here are the bearings. The connecting rod bearings are in two boxes. The main bearings are here, and the thrust bearing is in this box. We have just one of those, piston assembly, it's new. By the way, I didn't even check what brand or manufacturer it is. The manufacturer is some Chinese company, so it's not really clear. And also all the bearings we have are Chinese, and the gasket set is Chinese too. On this table I have the clutch, flywheel, pressure plate and disc. Everything here is staying old. I cleaned it, blew it out. We won't be opening up the compressor either. There were no problems with the compressor, it wasn't leaking oil. It was working well. I just cleaned it and blew it out too. Here's the fuel system. Long, low pressure pipes, high pressure pipes, and an interestingly designed rocker arm rail, which I'll show later. We're keeping the old push rods, that's our entire scope. Let's get started. We also see two large holes and one small one. This hole comes from the main oil channel. Oil flows here to the main bearing, and it turns out this hole is a blind one, meaning it's used on some engine models. Apparently there's another channel here, and this channel goes to lubricate the camshaft. I installed the crankshaft, tightened it with a gun, then finished with a torque wrench. We tighten it to 90 Newton meters, then put marks across at the stops and turn it 90 degrees to the stops so the marks are aligned. That means the tightening torque is 90 Newton meters, and then 90 degrees to the stops. So by weight, we see that two pistons are 1.931 kilograms each. The difference is 2 grams. The other two pistons weigh 1.910 kg and 1.913 kg. The scale still reads 2 grams and won't reset, so the pistons differ by 20 grams. Now I'll try weighing the pins separately. The weight difference isn't in the pistons, but in the piston pins. I don't know. I'll see, maybe they're using the old ones. Alright, I'll think about it. Let's weigh the old pins. 632. 32. 2. Identify key ideas and remove redundancy. E. Keep the original speaker's perspective. Preserve all names and numbers. E. Shorten sentences while keeping meaning. Ensure grammatical accuracy. Well, they're in perfect condition. I don't want to leave the new pins with such a difference. You can see they're from different manufacturers. I don't know how well you can see it on camera. This pin here has a straight groove inside, and these two pins have a kind of ridge, a flange. So this ridge adds extra weight. And also, for example, the new pin, as you can see, has some corrosion on it. Now I'll weigh the pistons separately. So I installed the crankshaft, tightened it, installed the pistons, tightened them, and temporarily put on the rear cover to see which bolts go where. I picked out the bolts. People ask me, how do you sort out the bolts later when you just throw them all in a pile? Well, since I'm working on this engine for the first time, I washed all the bolts and just sorted them out. It becomes clear which bolt goes where. Well, obviously it takes some time, but it's not really a problem now. I'm going to take off this cover, but apply some sealant and then install and tighten it. I also need to install the timing gear on the camshaft, and I'll be closing up the front cover as well. The front cover has also been washed and cleaned, and I'm keeping the old oil pump. Basically, judging by the condition of the bearing and the crankshaft, there are no complaints. So the oil pump here has this interesting pickup. One of the features of this engine is that it doesn't have an oil pickup tube. That is, the channel is already built into the oil pan itself. When I install the pan, I'll show you. So this is where the oil is drawn from the pan, and this is where the oil channel goes for lubrication. Here we have a relief valve that releases excess pressure. So here the oil comes out from here, goes through this channel. Here we have drilling blocks, and then it goes through the engine block. This is also an oil channel. So now I'm opening the gasket set. A complete set of gaskets has been purchased for this engine. I'm checking what we have there. I think this seal is here, but basically I'm replacing all the seals and checking which gaskets are available. And as I said, I'm closing the rear cover, installing the front cover, the timing gear, and along the way I'll probably also install the cover screw, the flywheel, the clutch basket, and the disc right away. I installed the timing gear on the gear. We have this kind of mark on the crankshaft, and we have a tooth with it. Basically the angle that was ground down during disassembly. I showed it for clarity, marked it with a marker. And I also marked these two teeth with a marker and aligned them. So we have 4 bolts tightening the gear, and 2 more hold this thing, which sprays oil on to the gears for lubrication, like little nozzles. Now I'll tighten this gear a bit more and mark the bolts to show they're tightened. Then I'll start installing the cover, the flywheel, the clutch basket, the disc and the front cover. Now I'll seal the oil pan. Everything's ready. I installed this plate, checked that the number doesn't match the number on the cover, and looked at how the oil nozzle fits into the notch on the piston. Everything is as usual. Checked the thread here for attaching the oil pan. So the oil pan is ready. I washed it, blew it out, and I wanted to show you the oil pickup. As you can see, it's built right into the oil pan. This is where the oil is filled and picked up, and from here the oil goes to the pump. The seal is installed right away. Thanks to the oil pan gasket, I prepared a new gasket, got the oil pan mounting bolts ready. Now I'm installing the oil pan, and after that I'll be installing the cylinder head. As I mentioned, the new cylinder head is fully assembled with valves, spring seals, etc. So, why was it purchased? Well, the main reason is that in this cylinder head, the valve guide sleeves are not removable, meaning they're solid and integrated with the head. They're milled here, and on the other side they're milled for the oil seal. Honestly, I've never seen this before. Where the guide sleeves, the valve guides are not removable. Well, you can kind of understand why they do this, so that the cylinder head is less repairable. Yeah, newer engines are less repairable. Everyone knows that. So, what needed to be done with this cylinder head was to put it on a surface grinding machine. Then, the valve guides had to be replaced. That means our machinists can do this too. They've already done it before. So they drill or sometimes mill it to a certain diameter, then either machine it themselves or use one from another engine. I'm not sure about that since I haven't really looked into it, but the point is they do it. So, They had to surface grind, mill it, machine it for the bushings, or replace the bushings, then ream and lap the valves. They also had to get new valves and valve stem seals as well. All necessary work on this cylinder head is complete. Well, it would have been a little cheaper than just buying a complete cylinder head, and that's why the decision was made to buy a complete cylinder head. It costs about 70,000 rubles. If I'm not mistaken, well, for me it's clear that it's better not to bother with these valves, lapping, reaming, and so on. Now I'll blow it out, take a visual look, especially at the fuel channels, to make sure there's no shavings in there. Well, basically that's it. And I'll install the cylinder head. And as for this old head, I don't even know. It'll probably just lie around here in the shop for a few months as usual, and then it'll probably go to scrap metal. So I'm installing the head. The head is new. We're keeping the old bolts. I washed them, and the gasket is from the set. So I installed the engine on the frame. I've already tightened the front mount and the rear mount. Now I'll install the rocker arm shafts here. Adjust the valves. I don't have the injectors yet. The injectors are with the fuel guys. I'll probably only get them tomorrow. Well, I just temporarily put the rail on for now so I can lay out the pipes on that side. Now I'll install the manifold with the turbo. Probably install the gearbox right away. Also put on the fan. And like I said, I'll put on the rocker arm shafts, adjust the valves, and basically that's it. I'll just wait. The injectors will probably be here tomorrow, closer to the evening. I'll install the injectors here tomorrow evening, close up the valve cover, and then the engine will be ready for installation. I'll try to record the car's first start as usual, but we'll see. Meanwhile, I'm continuing the engine assembly. I added the turbo, tightened it, and installed the rocker arms. Now I'm adjusting the valves, bringing the first piston up to top dead center for compression. To do this, you can either check the timing marks. There's a mark on the pulley, and the arrow should point up, or you can look at the valve overlap on the fourth cylinder. That means on the fourth cylinder, one valve is finishing closing while the other is starting to open, and at that moment, the first cylinder is at top dead center for compression and dynamic timing. If we check valve overlap, cylinder 4 is at top dead center for compression. So, also check cylinder 1's piston at top dead center for compression. And we adjusted both valves on the first cylinder, only the intake valve on the second cylinder, and the exhaust valve on the third cylinder. Then we turn the engine a full 360 degrees and adjust the remaining valves, meaning these two and these two. It's standard like on the Ozic, the 402 engine, basically any four-cylinder engine. So dynamic music. Intake valves are 0.35 mm, exhaust valves are 0.6 mm. So I've already adjusted these four valves. Now I'll make a 360 degree turn and adjust the remaining four valves. So my engine is ready. I've installed the valve cover, installed the fuel rail, the fuel lines are there, new seals here. In general, my engine is completely ready. So the repair of this engine cost this amount. So next there should be footage of starting this engine already in the car once it's installed. But that's it for this video about repairing the Cummins 38 engine. I'll wrap it up here. That's how our repair turned out. Thanks everyone for watching. Good luck to all. Goodbye.